Annual Hassan sir, Honorable Vice Chancellor of this university, National Urdu University, speaker, scientist at Indian Institute of Astrophysics, Bangalore, Professor Salman Ahmad Khan, Dean School of Sciences, Dr. Priyasan, convener for this international conference, Professor Syed Najmul Hassan sir, co-convener, Professor Shakil Ahmad sir, Emeritus Professor at our department, my dear colleagues, research scholars, students and participants from India and abroad, both in offline and online mode. Assalamu alaikum, namaste, sat sri akal. Now it's my responsibility to welcome you all for this international conference 2023 on astronomy data analysis with Python. मैं आप तमाम का इस्तकबाल करते हुए खुशी महसूस कर रहा हूँ. As we know, the physics section and Department of Mathematics of Maulana Azad National Urdu University are jointly organizing this 4-day international conference 2023 on astronomy data analysis with Python 2023 in hybrid mode. And it is a chain event for more number of such academic activities. On behalf of organizing committee, मैं हमारे हरदिल अजीज शेखुल जामिया प्रोफेसर सैयद ऐनुल हसन सर का तहे से इस्तकबाल करता हूँ और शुक्रगुजार भी हूँ कि उन्होंने अपना कीमती वक्त हमें दिया. बिल्कुल इसी तरह मैं डॉक्टर मार्गरीटा सफोनोवा का भी वेलकम करता हूँ कि उन्होंने आज के इस सेशन में कीनोट स्पीच देने का वादा किया. So, sir, there are around 50 participants who are offline from various parts of the country and around 250 participants from all over the globe. So, I welcome every individual through hybrid mode, and at the end, I congratulate both the conveners for arranging this kind of conference, which will be very useful for any kind of data analysis. Once again, a very warm welcome to all of you and wish a grand thanks a lot for giving me this opportunity. Jai Hind, Shukriya. Thank you.
Thank you, sir. We'll now have an address by our Dean School of Sciences, Professor Salman Ahmad Khan.
Assalamu alaikum and very good morning and warm welcome to one and all. Honorable Vice Chancellor Sir, Professor Syed Ainul Hassan Sir, today's program keynote speaker Dr. Margarita Safonova, Scientist, Indian Institute of Astrophysics, Bangalore. Dignitaries on the dais, off the dais and online join with us, our colleagues and dear participants. On the behalf of the School of Science, Manu, it is my pleasure to welcome you all to the workshop Astronomy Data Analysis with Python, being jointly organized by the Physics Section, School of Science, Maulana Azad National Urdu University and Inter-University Center for Astronomy and Astrophysics, Ayuka, Pune. I welcome all the delegates who have joined online and offline from the different parts of countries and abroad. In the beginning, I thank our Honorable Vice Chancellor, Professor Syed Ainul Hassan Sir, from the bottom of my heart for patronizing this workshop. To our delegates, I wish to inform you that our university, Maulana Azad National Urdu University, MANU, is a central university established by the Act of Parliament in 1998. The university is named after Maulana Abul Kalam Azad, the freedom fighter and first education minister of independent India. The main object of MANU is to promote and develop the Urdu language, to impart education and training through the medium of Urdu. I am happy to inform you that Manu has been accredited with a A+ grade by the NAC in 2023. Manu has 9 academic, technical, professional, training and research center, 3 directorate, 2 satellite campus, 8 college of teacher educations, 5 polytechnics, 3 ITI and 3 Urdu model school. The distance education program of Manu are offered through the Directorate of Distance Education, which has a network of 9 regional and 5 sub-regional centers spread across the 11 states of India. The Hyderabad campus offered education through 7 schools of studies which offer undergraduate, postgraduate and PhD programs. Among these schools, the School of Science was established 2006, offering various courses in mathematics, physics, botany, geology and chemistry discipline. In the present NAC cycle, the faculty and the research scholars of our school have published 275 plus publications with 24 books, a part of other academic activities. I am extremely happy to inform you that from this academic session, the subject in the undergraduate program will be offered to the student through the new education policy NAP 2020. The academic years are marked another milestone as we have introduced MSc program in botany, geology, physics and chemistry discipline. The university has accomplished another feat by admitting students into the MWalk program under the School of Science. All these became possible only because of broad vision and ambitious initiation of the Honorable Vice Chancellor from Syed Anil Hassan sir. Exploring the depth of any branch of science, always fascinating and enlightening. This workshop provide a great opportunities to research scholars and students to gain new ideas in their respective field. I am sure this workshop on astronomy will contribute to growth and development in the field of astronomy and astrophysics. My heartfelt congratulations goes to physics section for their joint effort organizing this international workshop with IUCA. Once again, I welcome you all. Thank you one and all.
Thank you, sir. Thank you, sir. And and now as behalf of the convener, I would like to talk about our workshop. So this workshop, as you see, is ADAP, Astronomy Data Analysis with Python. So what we have seen is ourselves, myself as a student, we did not do Python when we were students. We did C, we did Fortran. So even for us, it has been a learning process, but being a teacher, you have to be a student and continue learning. And therefore, we have also learned Python because that is the language which is being used now by total data analysis. So me with the co-convener, Professor Syed Najmul Hassan, we have been conducting various workshops in different parts of the country on Python data analysis for the simple reason that it is very useful. I mean, it is not even useful, it is very necessary. There is no other option, specifically in astronomy. If you want to do data analysis, I think it's almost only through Python. For the very fact that there are innumerable number of Python libraries available, it's open source, and therefore if you get efficient at using Python, for most of the tasks which you want to do, regression analysis, all kinds of things, you will find machine learning. You will find the software already available in Python. All you need to know is how to use it. And therefore we've been trying to do these workshops where we basically train master students as well as research scholars on using that, because this will be a very important component of their PhD work. So I would like to thank, first of all, our Honorable Vice Chancellor for supporting this effort on us hosting this over here, as well as the Inter-University Center for Astronomy and Astrophysics in Pune, which has funded the workshop, and our School of Sciences, the Dean School of Sciences, Physical Sciences, Maths department head, physics department head, all of us, we've got together to do this. And we really look forward to this because what we want to do in this workshop is we'll have some lectures, but most of what we'll be doing will be hands-on session. So the students are requested to, obviously, I've been telling them, get all your laptops so that we actually do hands-on session. The idea of having a smaller group is exactly that, so that we can have some amount of 1:1 interaction with students, so that we can actually help you in running your code and troubleshooting, debugging, whatever. So we really look forward to this workshop, which is 4 days of these sessions. Like you see, it's a long session. We start at 9:30 in the morning, get over at 5:30 in the evening. But the idea is so that we get up maximum output from the thing. So that's the basic purpose of the workshop. And I would request my co-convener to come and say some words also, because I think he wants to say something.
Good morning, respected dignitaries on dais. Most of it has been said and much more will be said as we continue. We have people from NCRA who are joining us. It's not that you'll be hearing only the two of us. We have a gamut of very good people. Sushan Konard from National Center for Radio Astronomy, Pune. It's one of the leading institutes, worldwide internationally recognized institute. She'll be here. Snehanshu from BITS, Goa, will be there. Tim Hammond will be joining in from the US. He'll be speaking on large-scale spectroscopy. And I hope you will benefit from some of the faces which I see have attended our sessions in Mathura and probably in Nagpur too. Like Priya mentioned, we had already 2 sessions on Python, one in Nagpur, then in Mathura. First was a 2-day program, next was a 3-day one, and this was a 4-day one. And there are innumerable lectures which we are trying to prepare and keep a repository on the net where you can go back and see again and again, right? And the issue is most of the time students don't know that there is high quality data available for everyone. The archival data which are there on the net. So how to access them? Then there's very good software which is available on net. There's a virtual observatory movement, and there are a lot of tools which we should be touching maybe this time, but mostly we'll concentrate on Python. So we'll indicate to you what kind of software is already there, what kind of data you have, and what kind of problems you can see. So we'll have people like Deshpande from Ayuka, he'll be talking on radio astronomy. Sushan Konard is a pulsar expert. And Akshay Rana. He is a cosmologist. In our interactions in the last 2 workshops, we saw that there are a lot of cosmology people. So Akshay Rana from St. Stephen's will be coming as well. So I wish you all benefit from this workshop. And I thank the Vice Chancellor for supporting us throughout and the School of Sciences to be a part of this all the while. Thank you.
Yeah. And I would request Professor Shakil Ahmed sir also to kindly give his comments on what he thinks about this.
Good morning to you all, and Assalamu alaikum wa rahmatullahi wa barakatuhu. Well, I'm really happy to learn about this international conference. And nowadays, everybody is talking about space, so definitely this is very timely. And in fact, I'd like to tell this one thing, because one thing is very important: data science, data analysis, etc. Because big data science is very useful nowadays, and everybody is working on that. In fact, statistics, if you see that, statistics is been older than mathematics also, because statistics gives you a lot of, it helps you a lot of to understand the numbers, to Like you see, they start from the basic. Everybody knows that mean and variance. Unless you know that, you can't have a feel of the data. In fact, and now with the advent of this new techniques and new devices, like even satellites are much more. So you are getting large number of data now. It will be very difficult. Luckily, we have the computer. Luckily, we have a lot of tools like machine learning as well as all these things have come. So this will definitely help. But then this is the need of the hour, because we cannot let this data, very useful data, go waste. So we have to analyze them, we have to extract the information, and we have to make use of that. So that's how this is very important. I'm very sure that this workshop is going to help us support this workshop. So we'll be doing a lot of work in this and learning this. And obviously, Python is a very useful software now. You will, of course, be developing some more things also in your own languages, other things. But then important thing is the data. Will make use of the data so that it will be useful. Whatever data you're getting, that it will be useful and develop the future programs also. So with these things, I thank you all for giving me this opportunity. Thank you so much.
Thank you, sir. And it being Teachers' Day, our Honorable Vice Chancellor will have to leave us at 10:30, and therefore I would request our special guest, Dr. Margarita Safonova, to briefly, for his benefit, tell him what she'd be talking about, because then her talk, but later on it would be anyway available on YouTube. But I would request Rita to give us a glimpse of what she'd be talking about.
Good morning, everyone. I thank Manu and organizers for actually accepting my registration. I actually came here to learn Python. Actually, astronomy is the fastest growing field of science with the data. And all because we are not just looking at the world around us, we're getting data from all the universe. So actually, astronomy experiencing data tsunami at present. And all the existing facilities produce something like terabits per second of data. And like simple example, square kilometer array, which will be built in 2030s, will produce more data in one day than the entire internet. So in that sense, the data is overwhelming. And I would like just to say a joke. Just recently, I tried to use one software, online software on our website of the institute, and it was not working. So I asked our computer guys why it is not working. And he tells me, we moved it to a new server. I said, so what? No, he said the new server, new computer doesn't understand the old language. And then this is the point, that we have to continuously, the same. Of course, in all my years of doing astronomy, I use from C, Fortran, IDL, everything IRAF, but Python is a new language. And I came here to learn Python because we have to learn. We have to learn continuously to continue work in astronomy. Thank you.
So thank you, Margarita. And now what we've been all waiting for is the address by our Honorable Vice Chancellor, sir, and we request him to speak a few words.
Speaker of this morning, Professor Margarita, Salman Saab, Professor Najmul Hassan Priyas, and Professor Shakil Basha. You know, the week of globalization. Now, a student of language and literature also learns so many things about sciences and particularly cosmology. Now, there was a time when we used to read science fictions, very, very, prevalent methodology of imaginations. Now, whatever we imagined in 50s and 60s, now it has gone beyond that imagination. I recall days when I used to read so many novels. One was James Hadley Chase. I don't know whether it is published even today. And then there was a person, Ibn Safi, who used to write so many things about space and spaceship and whatnot, in fact. And his characters, Faridi and Hamid, would travel all around the globe and discovering a new world also. So that was amazing. And he was talking, look at imagination in that. The novel, never visited, never did any experiment. But yes, talking about in the clouds and in the snowy mountains, you see, in a different planet and some kind of fighting going on within the clouds, and all these things, in fact, we could imagine all these. But you see, after NASA coming to existence, and I think after late 50s, I think it started. And now Python, Python earlier, if you say Python, this is enough to create fear amongst the people, but now Python is just right behind you. So these things are happening, and Manu is also moving forward. Our science schools are very important to them. And what we are doing, that we are creating integrated programs of introducing, MSc program in so many disciplines we didn't have. But now you see from this year you will find an MSc program. MSc is a link between the UG and the PhD. So therefore, I think this school is doing a lot, and we hope this is the age of collaborations. And I'm glad that Margarita is here, one more feather in the cap. And earlier, a person scientist from ISRO visited. And, all these, contemporary researches and activities and data collections are important for our generations, future generations, this generation as well as future generations. Because science is, yes, everywhere. And you see, within the sciences, if you find that one discipline which is physics, we say, even you tell this much, that is a physics. So you can't live, you can't survive without, knowledge of physics. And and I am lucky person to visit Einstein's laboratory also in Princeton, 2007, in fact. And I have seen through my naked eyes the kind of activities and the researches going on in the Princeton University in the Department of Astrophysics, and so many renowned professors who are working, I happen to come across. Now, this is the best opportunity when you meet a scientist, in fact. You must interact and see where the world is going and how to make use of this precious time. This is also important for us. Maulana Azad is wide open to have collaborations with n number of such prestigious institutions where she belongs to. Now, no, there is hardly any boundary today. You can transcend boundary, you can go beyond that, you see. And I will end up, by saying one couplet of Allama Iqbal, who says that सितारों से आगे जहां और भी हैं अभी इश्क के इम्तिहान और भी हैं. And I wish you, Priya ji, Najmul Hasan Sahab, Salman Sahab, I wish you all the best, Bashar, for a very successful brainstorming conference. Thank you very much.
Thank you, sir. Thank you very much for your kind words. And now we will, I will request Dr. Majid Chaudhary to come for the vote of thanks. Thank you.
Bismillahirrahmanirrahim. Respected dignitaries on the dais, Honorable Vice Chancellor Sahab, or guest Professor Margarita Safonova, Dean School of Sciences, Professor Salman Ham Sahab, Professor Sheel Sahab, Professor Alim Basha Sahab, convener of the program, Dr. Priya Hassan Sahab, Professor Najmul Hassan Sahab. A very good morning to all of you. It's my privilege to have been asked to propose a vote of thanks on this occasion. First of all, I would like to give my hearty vote of thanks to our beloved Vice Chancellor for gracing today's program. Thank you, sir, for being here and for your address. I would like to thank our speaker, Dr. Margarita Safonova, for your valuable time and glimpse of thought-provoking and interesting lecture. I would also thank our administration, especially Vice Chancellor Sahab, Registrar Sahab, for providing all the administrative permissions for conducting this program. I also take this opportunity to thank our beloved Dean School of Sciences for all your supports and help. I am very thankful to Ayuka for sponsoring this conference. Without their generous financial support, it would not have been possible to organize this conference. I would like to give my vote of thanking to all the teaching and non-teaching staff, all our research scholars, or technical staff for all the help and arrangements. Last but not least, I thank all who helped in any way in organizing this event. Thank you very much all. Now, I request all of you to stand up for national anthem. Punjab, Sindh, Gujarat, Maratha, Uttara Banga, Vindhya, Himachal, Yamuna, Ganga, Uchchal Jaladi Taranga, Tava Shubh Name Jage, Tava Shubh Ashish Mange, Gaane Tav Jaya Gatha, Jana Jana Mangal Dayak Jaya He, Bharat Bhagya Vidhata, Jaya He, Jaya He, Jaya He, Jaya Jaya. Thank you all. Jai Hind.
The keynote talk by Dr. Margarita will be after a short break. आपका 10:30 का प्रोग्राम है तो मैनेज टू डू इट इन टाइम.
Yeah, but sir, whenever you need to.
Yeah, so we, today being a Teachers' Day, there are many programs in campus, and Professor Ainul Hassan, our Vice Chancellor, is involved in most. Everybody wants him there. He was very kind enough to spare time to be with us, and we'll steal some more moments from him, and Margarita will start with her keynote address. Let me give a short introduction of Dr. Margarita Safonova. She was born in Russia, as we all have seen and heard and understood from her name. She received her MSc in Physical Chemistry from Mendeleev Institute of Chemical Technology in 1987. Then she did her master's, one more master's in physical sciences in Moscow State University. She's a very versatile person who has worked on diverse areas and hence the right person to be in astronomy, because astronomy today involves astrochemistry, astrobiology, astrophysics, and so on. And then she worked in Cambridge, UK, and later went to Tehran, Iran for a postdoc. She's been working in the Indian Institute of Astrophysics, Bangalore. She's a visiting faculty of MP Birla Institute of Fundamental Research, Bangalore. Her research interests are applications of gravitational lensing in astrophysics and cosmology, UV astronomy from space and near space, exoplanets, and habitability. So we have been interacting with Dr. Margarita Safonova from a very long time, and she very often comes up. She had come up with very strange ideas which we first heard and we thought were very strange, but later, after 10 years, we find that people are really talking about it. Like, it was the first time she was talking about floating planets, free floating planets. You know, we know about planets around our sun and other stars, but she had been talking about free floating planets for a long time, and today it has become a very important area of research. She is using gravitational lensing to detect, look at globular clusters and so on, and also Margarita has been involved in developing instrumentation which will be space bound. They have to go. She will touch upon the instruments they have worked on and developed. It was to go on an Israeli satellite, but then
Oh, Israeli,
Yeah.
originally, yes,
but
yes,
then
yes.
later it went with
Indo-Israeli.
yeah, it was an Indo-Israeli satellite which didn't come up, but later with ISRO the equipment is gone, and so she is a very versatile person, and you all will benefit from her being here. She is a life member of several prestigious organizations such as Astronomical Society of India, Indian Physical Association, International Astronomical Union,
It has to come
and the
through
Indian
this. I don't
Society
know.
for
Like
Astrobiology,
you
Education and Research. So with these words of introduction, I would give the floor to
Connection, slight
Margaret.
Yeah,
connection.
just 1 minute.
Slight connection problem.
Yeah, 1
Sorry.
minute. I'll just get it. No, I should keep this one only on, and she is this thing.
What's happening here?
I think here she's joined on Zoom. This one has to come on that. Javed साहब वो on है अच्छा वो off हो गया अच्छा wait आएगा
नहीं ये
आएगा
क्यों नहीं आ रहा?
लगाओ आएगा it will come.
Well, as an introduction, so while we're trying to connect, I would like to talk about space astronomy. In other words, why and how, or how and why, in that order. Space astronomy,
This is
so
the Zoom.
why do we need space astronomy?
This is coming.
No, as Edison said, knowledge of the stars leads through the atom, and important knowledge of the atom has been reached through the
One minute,
stars.
we need the
So since we are all connected, everything is connected, and it's good to know about what is outside us.
This is that other mode. Just flip the display. On display settings. Swap. Just a minute.
I should check it earlier. Last minute.
1 minute. Why is this not? Okay, just a minute. Just 2 minutes. Okay, let us.
I'll check this slide.
And here,
Which is
display settings.
ठीक था भैया वो
Oh, that's fine. Ah, you just go to screen. That's okay. Yeah, you put from there.
Okay, so then why do we do astronomy and what is astronomy? Well, there are different views. For example, purpose of life is the investigation of sun, moon, and the heavens, and that was said in ancient Greece. Yeah, there is something on the screen that is.
That. Just close
How
that.
to remove that?
No, just close that box.
There is something.
Over there is. Just clear it. I don't know, this pointer.
This is the one.
It's still there.
It's okay. Don't worry.
No, it is. I have some videos also. Some nice videos, and it will be like in the middle of the video. It's not very nice. See that?
This should.
You're on the second slide, this slide. Where is that thing coming
Any
from?
slide, it's just that.
I don't know, it's not here. I don't know why it's not.
See that one? What is that?
It's not like this.
Yeah. What is it?
I can't read it.
So maybe we can solve this problem eventually.
Yeah.
Please check what is it? What is it showing? Minimize it.
Yeah, it's gone now.
No. But it is not showing on my screen. That's the problem.
No, maybe it's going on this one. Correct. I'll move it. Yeah, it's gone. Now you're happy.
Yes. Okay. So, as I said, ancient Greeks knew the fun of the study in the universe. All the latest ideas about why we are saying entertainment versus science. As Neil Tyson said, I'm entertained by the universe every time I think about it. Well, astronomy is a unique science. It's simultaneously the most ancient and the most modern of sciences. The most ancient, like imagine ancient people seeing something regular going around, noticing the difference between day and night. Animals also know the difference between day and night, but unlike humans, animals don't count. Well, we know for sure that ancient people counted. And it is quite possible that it is astronomy that shaped our modern consciousness, our modern mind as it is now. It is also the most modern of sciences. And as we know that without astronomy, weather prediction, communications, we have all mobile phones, which are due to astronomy. Earth resources, which is very helpful. And it will be astronomy that eventually will help us, humans, to go out of confines of our planet and populate the galaxy. Astronomy is also a unique science because it incorporates in itself all the sciences. You can be chemist and still do astronomy. Only astrochemistry can explain how the origin of the elements on our planet. You can be biologist and still do astronomy because only astrobiology can explain how life originated in the first place. And as we know now, you can be data scientist and still do astronomy because without data, without the big data analysis, and astronomy now is not possible. But when we look out in the sky, all we see is space. After all, the space is the definition of nothing. Between us, there's space. So then what do we study? I don't understand why it keeps on doing this. So, to begin with, our sun is not just sitting there quietly. It's a flaring, gobbling, comet's active sun. It is so active that space between the sun and the earth is not empty at all. This is a movie which shows how coronal mass ejection reaching the sun, the earth from the sun. It's a short movie, but it is very interesting because it shows that there is a lot of stuff just between us. Why didn't flicking? Unfortunately, I'm sorry about that. It's not my, there's some problem with the connection setting. No, what?
Sleep mode.
It's going in sleep mode, that's what it is.
No, it can't go in sleep mode during the presentation. It never does. And so that this is our understanding of the area of the space around our own planet. As you can see, it's not empty at all. There's a lot of physics going on, a lot of processes. And if you go a little bit out till Oort cloud, there's a lot of stuff. And then there is a heliosphere. So, universe also produces a lot of, sorry, there's a lot of information coming to us from the universe in X-rays, supernovae, black holes, gamma rays, ultraviolet, visible, all that we can see in the sky. Then there is infrared, radio, microwave. This is just electromagnetic spectrum. There is also gravitational waves, neutrinos from sun, from Big Bang itself, cosmic rays which sun produces, the galaxy throws at us, meteoroids which are all around us, our cloud, asteroid belt, and so on. So actually, there is also dark matter and dark energy, as we know. So universe is actually bombarding us with the information. Bombarding. And we have, this is what astronomy is about. We have to understand it. But why go to space? We can do it from the ground. The biggest show on Earth every night, played by everyone for free, is actually the night sky. By the way, can somebody tell me where was this taken? Where was this image taken? On Earth? Huh? Anyone, any guess? You're trying to do astronomy, no? Sorry? Yes. Oh, pole, on the pole. Yeah, judging by the landscape, North Pole. Close to the North Pole. What about this one? Equator, correct. Okay, so why we go to space? Well, to begin with, Earth is a spaceship. We do not sit still. Earth rotates, orbits the sun, solar system moves, Milky Way rotates, and so on. And then there is also a universe that is expanded. And another reason is dinosaurs became extinct because they didn't have a space program. Larry Niven, very famous science fiction writer, said. It is estimated that about this many near-Earth objects exist around our planet. We are aware only of 1% of them, meaning that any time asteroid can enter our atmosphere and cause widespread destruction. We can track them from Earth, yes, but tracking and defense best from space. Here is the movie about this is just in 3 years, the detection from WISE, it's not showing, WISE Observatory. Discoveries of near-Earth asteroids in just 3 years. So, in other words, eternal vigilance is the price of freedom from going the way of dinosaurs. Another reason why we go to space is something we astronomers call seeing. Turbulence in the atmosphere causes images to blur, as you can see from this image of the moon at 1 second space, and it's flickering. Increasing telescope size increases the depth. Faint object can be seen, but not the resolution. Another earthly problems, dust, smoke pollution, light pollution, like this. Moon, clouds, This is an image I tried to observe through our Hanley telescope. There was a moon and the clouds. You can see, and nothing can be seen. Temperature changes affect optics, traffic noises affect gravitational wave antennas, radio phones, even microwave oven affect the radio telescopes. And then recently we started experiencing more, let's say, night sky pollution from the satellites. Well, we can't get rid of the satellites. It is impossible. We need them. Everyone wants internet, fast internet everywhere. So, but this is the actual image of the sky with the Starlink satellites. And the idea is that this, unfortunately, this is not the sleeping of the. Why it is happening, I don't know. And in other words, those satellites produce space junk, and this is the European Space Observatory video of how the space junk, how much the space junk exists, and this is the recent image of actual space junk, detected space junk, with different sizes. So what shall we do? Maybe we should try to solve this problem.
I don't know.
Seems to get worse.
There is a delay, there is a lag.
There's a lag.
The lag is okay, but what happens is that, and then there is a, but here it is not doing this.
Why can't you connect directly?
Yes, why can't you? Then there is also atmospheric turbulence, transparency.
Ravi.
And we know
Ravi. इनकी उसको ही directly connect.
transparent doesn't allow us to observe in certain wavelength, which is good for us humans, like for example ultraviolet, but not very good for ultraviolet astronomers. So ultraviolet astronomers have to go to space to observe in ultraviolet. So unfortunately, we have to do something because it is now flickering every other second. Can I maybe copy on the pen drive and put on your computer?
Yeah, we can do that also. Or ये इनके उससे output करेंगे क्या?
Sorry about that.
Ravi.
Thank you for listening.
Okay.
Thank you, sir. Thank you, sir.
कि इनके से ही output करेंगे.
इसका स्लो रिकॉर्डिंग में चले जा रहा है बार-बार इनके उसमें डायरेक्ट
हाँ,
लगा दीजिए आप
correct. वही कर लेना. वही करना. It should work.
Yes, we have to solve this problem, otherwise it will keep on persisting. But other.
अब ये output क्यों नहीं आ रहा है इसमें से?
हार्डली 1 मिनट
हाँ, ठीक. Actually उनका full desktop screen पे उन्होंने तो share किया ना. अच्छा आपने share कर देना. Okay, so no, it's when I do. Okay, चलिए ये आ गया ना. तो we just close this. Yeah, वो उठा दो आप. ये इनपुट कौन सा है? सेम ही होगा ना?
इनपुट
Some of that HDMI port is not giving the output. हाँ, देखो आ रहा आके जा रहा है. हाँ, अब ये ठीक है ना? Yeah, we can do that otherwise.
C connected on
What can do?
C.
अब आया ठीक that you can do that, you just pull it up. That's not a problem. Pull it down. Let me check it. That's it. That's all.
Okay, hopefully it will work now. Okay, so atmospheric transparency allows us to observe in radio and visible, but all the other wavelength ranges, we have to go out in space. And why? Because different wavelengths reveal different physics, and in different wavelengths, the things look different. For example, the same Whirlpool galaxy looks completely different in several ranges. I don't know this. How this thing is obscure.
There is a mic here.
Huh?
Unmute.
Where is unmute? Put it down. Why did it so?
And for example, our Milky Way also looks completely different in different wavelength ranges. Well, X-ray astronomy has to be outside of the atmosphere because X-rays are so, and there is a massa named gamma rays, most energetic magnetic radiation in the universe have to be outside. And the constant gamma ray looks like this. Infrared astronomy, picture. This is very good satellite which is still being continued and will be used for years and years. UV astronomy. One of the most exciting parts of the astronomical spectrum is UV astronomy, spectroscopic and photographic. In the imaging domain, UV sky is faint, sources are few, so transient. The objects from near Earth to supernova, they really stand out. So supernova in optical are caught too late usually, and in UV it's already fading. So early detection is very important in understanding of this supernova. And here we can actually use small telescope, CubeSat, and monitoring sky in UV. We can catch flares from disruption of stars, from by black hole, also M-dwarf stars. So UV astronomy is really important. Here, for example, due to that, India launched Astrosat, India multi-wavelength mission, and still operation, observation, and this is the actual view of the spacecraft with this X-ray, which also does somewhat spectrum scanning, monitor. and the terrain was inside. So the idea is that if there are meteoroids, how will be function? Temperature will drop immediately, and then the radio will transmit the temperature, and we will know that it is not so. 3 months it was flying, so it was known that yes, the space near Earth is quite safe for instrumentation or even, as you know, Gagarin. So space Sputnik 2 in 57 November was bigger, like had a lot of information than the do. And I'm sure that everyone knows the Leica, very cute one. Then Sputnik 3 was launched in 58, 1.5 ton satellite containing lots of scientific instruments. Now America is doing. In December 57, they tried to launch embarrassingly small, just 1.6 kg satellite that exploded on the launch pad. But then finally, in January 58, they launched Explorer 1, they discovered radiation belts. The payload was built by Professor Van Allen, and that is why now these belts are called Van Allen belts. So, in principle, space astronomy started very humbly with the rockets and balloons. We're not just launching rockets just like that. We're actually detecting astronomical sources. Like for example, in 49, a V2 rocket detected first X-ray. In 62, detected sources from a Scorpio X1 neutron star. The drawbacks of rockets, of course, they just stay. They really can detect only very small. Balloons are better. So there is a funny joke about balloons that in 52 Canberra Times newspaper printed an article in which one Mr. Park claimed that it will be possible for humans to fly to Mars with balloons if anyone is willing to invest this much money. Well, dozens of balloons were flown, and from Goddard Space Center, from PRL, India, observing Scorpio X1, and aeroplanes. There is only the keeper on the orbiter carried it worked for 20 years. So many runs really inside and so on. And space telescopes started in the 60s itself, and
This is better.
not connected. This is not connected.
She's saying it's not connected.
No, but there it is. It is
So after that, it just kept going.
the
So
is
now
better now.
there are
Okay.
at least 7,000
It's audible
artificial
now.
satellites
I think
orbit
it's
Earth,
fine.
more than astronomical, and nearly 1,000 observing the Earth. And by the way, this year is important year. It is anniversary for the Hubble Space Telescope because it is exactly half as old as the whole space age, 33. And the space age now, so it's anniversary. So what is all this? That all this space satellites are doing? So there are different orbits. So there are orbits, like what we know all of us, Leo low Earth orbit. So ISS roughly up to 2,000 kilometers. Then middle Earth orbits, GPS satellites are there, and high Earth orbits, gestation. About this is high Earth orbit. So this is outside the radiation belts, and low Earth orbit is inside the radiation belts. So low Earth orbit, there are also different orbits like polar orbit, equatorial orbit, sun synchronous, dawn dusk, and so on. It's full of debris right now. Currently being collected, so the picture, more than like 1,009,000, much larger than 10 centimeters. And Sivo suggested at some point that there could be alien objects, space debris, all the remains of the satellites. Middle of orbit, there are semi-synchronous orbits, there is polar orbit, Molniya orbit, these are Russian satellites, which are very highly elliptical, and yes, GLONASS, Galileo, and all these satellites. This is highly elliptical orbit. High Earth, geosynchronous. So it's exactly the traffic 1,000 kilometers of the equator, Of course, is centrifugal. So ideally, park. Now there are so many of them there that separated by 30 kilometers in space. They actually started colliding already. So they're good, broadcast, we need them, radio, TV, and so on. Time lag though presents problem for voice communication and online gambling. Like 253 milliseconds one. By the way, in Inaugural, in Margarita, I think, school, and everyone was saying, yeah. So, these points are analogous to geostationary orbits in that they allow to be in so-called fixed position in space. So they are in rotating systems. Here, here L1, L3 correspond to saddle, so they are L4 would be hilltops and left. So L1 is where the and a small body partially cancels traditional model. So, for example, between Sun and Earth, this is ideal for observations. So there are lots of telescopes existing already. Then, so being deep space cluster, for example, Discovery is able to provide 15 to 60 minutes before the solar storm reaches it. So, and these are also so-called halo. Of course, it's so-called fixed position. They're not just sitting there because everything is moving. Even the solar system is moving. So they do what is called halo orbits. You can see it's actually a small, constant rotation around this point. And so is I didn't put comments, but it's constantly discovering. Actually, you can go to SOHO website and they invite people to come look at their videos and discover comments. Actually, science project. And this is that our moon is actually within our atmosphere. Something part of our atmosphere is called geocorona. It actually has much more than wind. So then there is the point 2, which is on the other side of the smaller object, like for example, on the other side of Earth, and it is perfect for deep space observations. It is quite close to communicate with Earth and still already far away from the Sun. So that it provides very good view of deep space, like Herschel, one activity is Gaia, and we will teach us about Gaia using Python. And there also getting quite crowded. And we have China's lunar mission, Chang'e-4, the relay station is there also. Because Chang'e-4 landed outside of the moon. So to reach the Earth, the crews have to go through L2 state point. JWST already provides a lot of discoveries, lots of data, tsunami of data, and it is in what we call hello orbit. Here is an explanation of what is hello orbit. Can you remove the lights? Maybe you should switch off some lights.
Yeah, these lights. Sir, yeah, sir, light band karo. Mat kar do.
All the lights. Yeah, and there also. And so
Yeah,
I
that's
hope
good.
everyone can see the simulation, how the hello orbit around L2 works. And here is a little more explanation about how orbit can be thought of controlled drifting to remain in the vicinity of the L2 point. So this is what we call station keeping. So every time, just like ISS also has to do with the station to prevent the falling on the Earth or regular boosting up. So here it is constant station keeping. But this hello orbits are quite stable. Then L4 and L5. So these are stable only in a rotating system due to periodic force. Again, here I explain what it is. So, and for example, we recently discovered that our Earth, L4, there are actually asteroids rotating around. So they are constantly orbiting Sun together with us. And the orbit is stable. L4 stereo there. This is all the way. So, and you go to this website, and there is forgot to attach, but it will always show you positions of stereo ahead and stereo behind at current time. It's still operational. These two satellites are still operational. So from this website you can get this map of where they are. Then we have planetary missions. Of course, Moon, Luna, 1 to 24, 25 I will count, Chandrayaan 2, 3, Mars, Mangalyans, Mercury, and so on. Mission to comets. So this mission to Mars, this is, for example, interactive map of the global topography of Mars with all our landers there. Actually, it is very interesting. You open it, you click, and it will give you all the information about that lander, about where it is, show you the images, the video. So this is how many missions to the Mars we have, this map, as you can see. And somebody said there is no life on Mars. There is life on Mars, and it's ours. And you can see that. So Mars orbit mission, Indian, Mangalyaan, of course, produced amazing images of Mars. Unfortunately, yeah, it was decommissioned last year, but it was designed to last only for 6 months, while actually it worked for 8 years, producing these amazing images. So now we can actually see other planets' surfaces in real time, nearly real time. As you can see from this movie, so I'll just show you Mars. Not the movie, it's actually a real video of Mars.
Yes.
Or the Moon. And this is really near real time. Happened just a few days ago. Deployment over. Well, now we can see nearly the surfaces of other planets and actually surrounding areas of other planets. For example, image from Cassini led to discovery of these geysers. And these geysers shoot out water and organics. So there is an idea that Enceladus can actually harbor life in its underground salty ocean. Here it took the selfie. I hope you understand which planet is that. Then we can see images of comets. For example, Rosetta caught up with a comet 67P in 2015 and actually took fantastic photographs of the surface of the comet from 50 to 51 meter to the actual. This is that Philae, the lander. Unfortunately, it got lost. Nobody knew what kind of a surface the comet had. Everyone thought it's smooth, but as you can see, so it actually toppled and went into this hole. So, in 2015, we celebrated the end of humanity's initial exploration of the solar system, as now every planet has been visited. And now we're proudly marching into interstellar space. For example, Voyager 1 launched in 1977, and it is still continuing its growth into interstellar space, and scientific data will continue till 2025. Recently they lost communication, but they restored it. So, and here is us. And here I would like to pause. And because till now I was talking about how and what, but what about the question why? So as you can see, this is us. Or even this is us. Living in this. Living in this is local group. 1 million light years. Living in this. Living in this in the supercluster. The cluster of superclusters. Living in this. How do you feel? How do you people feel that we are so insignificant? Just look, you can't even see our supercluster in this, not to say a human being. Do you feel down? Do you feel sad? Tell me, how do you feel, people? Somebody, say something. Do you feel good? Do you feel bad? Do you feel sad? Do you feel insignificant? What? Humbling. Humbling. Okay. Any idea? Other idea? People, I think we are awesome because we understand this. We're so tiny and insignificant, like smaller than bacteria or whatever, atom. We understand the whole universe. We actually understand how it originated, how it, all its timeline. We know that. We understand this using this. This is a Hubble Space Telescope. And this is all dark matter, galaxies in the dark matter halos. And life begins with the birth of the universe. The hydrogen in us was made in the Big Bang. Everything was made in other stars, scattered. We are natural product of the universe. We are the universe. And we can proudly say, the universe is my home. And that is why we need space astronomy. Because space astronomy tells us about that. That's why question about space astronomy, why and how. Okay, if we have some time.
Yeah, we do.
Yeah?
We do.
I also would like to say a little bit just what our group is doing at IA. So all these huge space missions and all, they are very expensive. Space comes at a cost. So what makes space astronomy expensive? Hardware, reputation, reliability, size, launch. Launches are very expensive. Like for example, Hubble space mission costs $10 billion. ISRO charges for just for some small launch $25 million. And all these are prices of the missions. But big science not necessarily has to be from big groups. Like, as you can see, this nice cartoon, which I mute.
Yeah. Huh.
Like, one person can do big science and a huge group can do not so much. Nice cartoon. So, science on the cheap, what we call it. Small telescopes, cameras on board, balloons or sounding rockets are still not forgotten, they're still attractive. Oh, now, after all, the first UV spectrum of quasar was actually obtained during short rocket flight. Of course, there are some CubeSat, nanosats, but outer space station are one way, no return, no correction. It needs space qualified equipment, still requires extensive launch. So, we started our small payload program in IA in 2013, starting with balloons, because balloons allow you to correct whatever is wrong, to test your equipment on the balloon launch, stratospheric balloon launch. This is how we started. This is our CREST facility in Hoskotany, Bangalore, from where we launch our balloons. So this is a short video of our launch. This was atmospheric launch. We were measuring ozone in the atmosphere. That is why it is in the day, in the morning actually. But usually now we launch only in the night. So this is some of our photographs from stratosphere, balloons. Then as they go up, they start bursting. This one balloon has burst, and then the parachute opens, and the payload comes down. So some of the instruments, we do develop our own instruments, like flight termination unit, for example. We don't want the flight to be more than 1 hour, for example, or go into the other state. So we usually put 2 flight termination units, timer-based and GPS-based. And all the star radio decoders. So we started having our what we call space spin-offs. Here, please to tell me something about our small space instruments, and I will say quickly. So our CREST facility, we have testing. So it's MT-Kaminan laboratory. It has clean rooms up to 100, and we can all flight qualification tests, vibration test, and thermovacuum test. We can do all. So our first payload, actual space payload development was with LUCI, which we call Lunar Ultraviolet Cosmic Imaging. It was designed to fly on Team Indus to the moon. As you must have heard about Google X Prize Foundation, which had this moonshot. So India was one of the contenders, and they developed and built the lander. And our telescope was supposed to be there. But then ISRO got stuck with Chandrayaan-2, and they kept postponing the launch of Team Indus, and finally Google Express deadline passed, unfortunately. So now Lucy is sitting in the clean room. This is in the room alignment. This is the instrument, and here it is in a storage box in clean facility, waiting for launch. Here is the real photograph. Then we continued with our development. We developed a near ultraviolet transient surveyor. This is a telescope, which is also was supposed to have launched, but again there were delays, and again it is sitting in the clean room waiting for launch. Then recently they were announced flight opportunities, like ISRO announced on orbit scientific experiment orbital platform PS4. As you know, the stages. So first stage dropped very early. The fourth stage dropped already in low orbit, and it just orbits the Earth up to about 6 months. So ISRO thought, why wasting that? When actually that can be used for any scientific experiment, especially if they manage to stabilize it. So this was the first experiment on stabilization, plus on the several experiments on it using that stabilized platform. So that's what we launched our star sensor, developed by one of our students. And another opportunity was announced on Chinese space station. United Spinoza announced it, and we won the competition. So this is our PS4 opportunity. This is a photograph of our star sensor. This is a buffalo. It is based on Raspberry Pi imager and computer. Yes, and it flew. And here it flew this April. And this is the rocket, the bus, what we call the bus. And here is ON, the SLV orbital experimental module, and here is our star sensor sitting. And it's actually flew and it take data for about 4 months. Then civilization went off, and it was at the end of the 4 months, it was already tumbling so much that we got images of the Earth, not just of the sky. So then Chinese space station, here the only ultraviolet spectrograph in space now is on Hubble, which is like 33 years old. So we proposed ultraviolet spectrograph, and it was accepted. It's called SIM, spectroscopic investigation of nebulous gas. Here is the Chinese space station. Looks like this. So this is the first time astronomical telescope will be operating on space station. On ISS has telescopes, but they all, like 2, I think, ultraviolet telescopes, they all look down at Earth. There is no astronomical telescope looking up. So here we'll be sitting like this. This is the model of our telescope, and this is how it will look. And this is how it is looking now. Just a few days ago, it is nearly a sample. This is the spectrograph part, and this is the tube with the mirrors. So this is assembly in our MJ Inaugural. And this is our future proposal for seeing is NUV, and this tiny is FUV, which is a collaboration with Tübingen University in Germany, and they're providing us with the detector. So that's it. I hope that I didn't bore you too much, but on the contrary, I hope you're excited about space astronomy.
Yeah. Thanks a lot. Thanks, Margarita. We'll now open the floor for questions. Yeah, so please, feel free to ask your questions.
I'm here, so we can talk later.
Yeah, and like I mentioned, I told Margarita specifically to talk about the work they do, because you may have this impression that these very big bodies only do things, but at all scales you can do work, and they're doing very good work at that stage. So please, questions, please. We want this to be more interactive. We want questions.
No, but in other words, yeah, if they have, well, maybe they already tried. I'm here for this week, so anybody can contact.
Yeah, Mudassir will. Yeah.
Call up 1 minute.
Sorry?
Battery down.
How can we map the universe with that? How does that work?
Oh, you can't map the universe with the but these are very specific fast radio bursts. They're very specific from very specific sources.
Click the log to make changes.
Well, I'm actually not a radio
किसी को कुछ
scientist.
करना नहीं देते ना, अब शायद
I was talking about space astronomy. FRBs are detected on the ground with radio telescopes. So we can talk about it a bit later.
1 minute.
Right now, I can't answer this in a few words. Very complicated question.
once वो क्लियर होते हैं फिर यहाँ कनेक्ट करके
फिर टी ब्रेक है ना अपने पास टी ब्रेक का इसी को
लाइट की बात करेंगे लाइट की बात करेंगे
So, the space variations are challenging in terms of vibration. How did is Raspberry Pi did the vibration testing part? Was the market module really well, or did you make some changes to make it space suitable?
So this is a good question, and actually this Raspberry Pi was very interesting because we got them during lockdown where there were no Raspberry Pis in India. So my friend from England, actually from Cambridge, sent to me several of them, and then we got Raspberry RPi camera. Yeah, it was amazing demonstration. See, the problem is that, I mean, not the problem, the point is that this PS4 was not supposed to operate more than 6 months. Yeah, so, and this was one of the demonstration of how long can ARPAI survive in these conditions. Yes, so we know for sure that at least 4 months it survived. And it is a very good point. It may not survive prolonged exposure to space, like for example, for years. But as I showed you, we have the thermal test and we have the vibration test, and we even tested it for what is called shock test. Shock test. In Bangalore, we didn't do it in our institute, but in Bangalore there was some company that actually did this. So, and amazingly, it survived. It has survived, yes. For 4 months at least, Raspberry Pi, and it's cheap, and it's amazing. You can do astronomy on the cheap, indeed. Short-term astronomy, yes, but it's still possible. I should have put the images. Okay, I can. We are writing the paper. Paper is not finished yet. They're submitting the paper within a few, maybe 1-2 weeks, with the actual images that we got. And as I said, that it worked. It worked when the platform was stabilized initially. It worked perfectly. At the end, it started tumbling, and we got images of the Earth and of the Earth limb. Yeah. Okay.
Questions? Yes.
So I hear that we have detected using gravitational lenses globular cluster. So what is the procedure?
Sorry?
Gravitational lensing in globular clusters.
Oh.
We heard that you.
How can we?
Okay, yes. So globular clusters, this is another project which I'm working on for many years already. And the point is that globular clusters are very interesting objects because they're compact. And they're compact and bound. And there are different theories about, for example, what holds them to be compact. What holds them? There is a theory that in the center there could be a black hole. Just like in the center of most of the galaxies, there are black holes. Only in the galaxies there are supermassive black holes. But in the center of the globular clusters, there could be intermediate mass black holes. So there is a theory which is not proved yet. Because as you might have seen the picture of globular clusters, it's very dense and compact. You can't actually look through to measure the standard way of measuring, calculating whether there is a black hole in the center or not, to measure the velocities of stars around. Like this is what was done in our galaxy. So in this sense, in the center of globular cluster, you can't penetrate through those foreground stars. So, but I proposed the idea with my collaborators that we can actually look for micro lensing, for lensing events. So if it is a massive black hole, it should produce lenses. Yeah, you must know all about gravitational lensing. So stars in global clusters, just like in any galaxy, stars always move. They keep orbiting. So if stars moving, micro lensing means a transient event. So the brightness of the star, of the two images combined, increases, and as the star passes by, again it decreases. So this curve is a unique signature of gravitational lensing, because the curve will be also symmetric, unlike most of the variable stars curves, then are asymmetric. And another idea is that because of high density in the globular clusters, well, we know now that there are billions of planets in our galaxy, just our galaxy. Every star has a planet, at least a planet, not to say planetary system. So the same would go for the globular cluster stars. But because due to high density, those planets will be broken off their orbits and become free-floating planets. They will just share and keep on moving around, just like stars. So looking for those planets, I suggested using the same microlensing. So if you observe a global cluster continuously for several years or for several months, whatever is the calculated duration, so there is a probability that you can catch that event in a global cluster. This is what I'm working on. I haven't caught yet, unfortunately, but
Yeah.
I still hope.
Yeah, so Rita's going to be with us till Friday, so you can catch her at any other point of time. So thanks very much. We now have a short tea break. I'm sure you need the tea. So tea is out here, tea and biscuits. And then at 12 o'clock, we continue again, right? Then I'll give one talk for 1 hour and then we go for lunch, right? You have the schedule, everybody has the schedule. So please join us for tea. It's outside over here. Please note that we are doing this on a very informal ground. So our friends who are serving you tea also are our research scholars, right? Like you and me. So please help yourself. Like I said, it's more of an informal tone. The people serving you tea are research scholars, right? Mostly mine also serves.